Here we have objective 1, where we are practicing using an analog write function using the Arduino pulse width modulation PWM and a function called analog write. We are able to change the output voltages. Depending on the PWM's output, we are able to dim the LED. Here's a look at our code with the different values of the PWM's duty cycle. Here we have objective 2. We use a DC supply and a DC motor. We also use a potentiometer POT to vary the input voltage to the DC motor. We also use a multimeter to measure the flow across the motor at 5 volts, and we came up with 2.6 amps. And the maximum current the Arduino pins can source is 40 milliamps. The downside to this method of control is once the motor is on, there's no gradual buildup. Here we have objective 3, where we are controlling the motor speed using the Arduino. Here's a diagram showing our schematics of how we hooked up our lab. We have our 9-volt battery hooked into a breadboard. We're just hooked in contact with a potentiometer, which controls the speed of the motor, which is hooked up to AO and to the positive and negative sides of our breadboard. We also have incoming from pin 9 to our transistor, which is hooked up to the motor, and the diode, which goes back into our loop with a positive and negative side. We also have the code for the DC motor speed control circuit. The potentiometer controls the speed of the motor by the PWM's output value. Here we have objective 4. We set up a digital push button and a potentiometer with our motor and our 9-volt battery on our Arduino and on our breadboard. Here's a program that only turns on the motor when the push button is pressed and the POT value is above 500. If the value is below 500 or push button is not pressed, the motor will not operate.